We are going to focus on identifying x and y intercepts. Definitions. The x and y intercepts of a graph are the points where the graph intersects the x and y axes. So given an equation in x and y, an x-intercept is a point a, 0, where a graph intercepts the x-axis, while a y-intercept is a point 0, b, where a graph intercepts the y-axis. So now we're going to look at 3 different graphs, and we're going to identify the intercepts by inspection, if we can. So for the first graph, we want to look at the graph and see, is it intersecting the x-axis or the y-axis at all? And we can see that it is. So for the first point of intersection we have right here, which is the point -2, 0. And I can name that because, as we've talked about before, scale is indicated in all 4 directions, so I can name that point. The next point of intersection is both an x-intercept and a y-intercept because it's the origin. Notice it's meeting the definition of an x-intercept because y is 0. It is also meeting the definition of a y-intercept because x is 0. And then the last intercept we have right here, which is 2, 0. Now for example letter B, this is an interesting example, and this is why it's so important to take some time to read your scale. So here I can clearly see that I have an x-intercept because I see that x is 0 and y is 6. Pardon me, y is 0 and x is 6. I got that reversed. So this is 6, 0. Now at first look, this looks like it could be the y-intercept, doesn't it? But do you notice the x value? The x value is 4. And so that cannot possibly be an intercept if x is not 0. So we're not sure about the y-intercept. We cannot tell because we do not see what y is when x is 0. For the last one, this is a circle, and so we can see that we have a y-intercept at 0, 3. We also have a y-intercept at 0, -3, and we have 2 x-intercepts at 3, 0, as well as our last one, -3, 0. So your first question is, what is the y-coordinate of any x-intercept? Now I'd like us to work on finding x and y-intercepts. Now recall that to find an x-intercept, we're going to let y be 0. So I'm going to do that directly. I'm going to let y equal 0. So 0 equals x minus 4. And I could either add 4, or I could recognize that this is going to happen when x is equal to 4. So writing this as an ordered pair, I let y be 0, and that resulted in an x value of 4. So 4, 0 is my x-intercept. Now to find my y-intercept, I need to let x be 0. So y is equal to 0 minus 4, which gives me -4. So my y-intercept is 0, -4. That gives us our input and our output. Now the next one is a little bit more interesting because we have absolute value. And remember, definition of absolute value is it is equal to x if x is greater than or equal to 0, but is equal to -x if x is less than 0. So we have to think about both conditions there. So first, to find my x-intercept, I'm going to let y be 0. So 0 is equal to the absolute value of x minus 4. So that's going to happen when the absolute value of x equals 4. And that will be true when x is equal to 4, but also there's another solution. It is also going to happen when x is equal to negative 4, because remember the absolute value of negative 4 is 4. So that's going to solve that as well. So we have two intercepts there of 4, 0 and negative 4, 0 for our x-intercepts. And then for our y-intercept, we're going to let x be 0. So we have y is equal to the absolute value of 0 minus 4. Well, the absolute value of 0 is 0, so that gives us negative 4. And so our y-intercept is 0, negative 4. And your last question is find the x and y intercepts of the equation negative 2x plus 4y equals 12.